Welcome to the graveyard shift. All right, so REACH is trying to improve access to water security for the poor. You might remember that the recently approved SDGs talk about sustainable water management for all and sanitation for all. And I want to talk about how we might try and integrate into that problem the question of environmental conservation, which is what my organization does. For those of you who don't know us, TNC is an environmental conservation organization. We're about 4,000 people in 40 countries around the world. And I wanted to start here, because this is, I think, a good picture of the problem I'm trying to describe. This is a picture of Sao Paulo and its watersheds. Some of you will recognize the Cantareira system, which is kind of the one that got in trouble last year. The point I'd like to make here is that if you look at cities, large conglomerates of people, and the landscape that they depend on for their water, this is where Sao Paulo gets, at the bottom there, gets its water from. You realize that one of the most basic forms of infrastructure that we rely on is, in fact, the underlying watershed and the ecological function that supports them. The question I'm trying to answer is, what can you do to this to improve access to water for the poor? Does it matter? Maybe it doesn't, but can you do something about it? And if you can, how do you scale, those practices? Okay, so that's one point. It matters because it's also an issue of equity. You might have noticed that Sao Paulo draws its water from very, very far away. In fact, even though the Tietê River goes through the city, the Tietê is too polluted to be used, and so most of the water gets piped in from quite a distance. And this is actually a story that's true across the world. Many cities end up having to move water around. If you were to look at the same picture for, say, San Diego, you'd recognize that water is coming out of the Colorado, which is over the other side of the mountain range. And of course, this poses an issue of equity, not equity in the sense that this audience has been talking about, not intranational equity, not a Gini coefficient type equity, but certainly international equity. This is a picture of where 500 cities get their water from, and they're divided between the top quartile and the bottom quartile by GDP per capita. The first column is local source, the second is transfers that require large amounts of conveyance infrastructure, third is desalination, and the fourth is groundwater. And the very basic point that this graph does is that if you actually look at where these 500 somewhat representative cities of the world there's a high correlation between your ability to draw water from very far away and your wealth. And so if the solution that we are trying to rely on to solve water security writ large, and then water security for people, poorer people in particular, is ultimately re-engineering, replumbing the natural infrastructure that we have, then it's going to be disproportionately accessible to the wealthy and not to the poor. Now, why am I talking to you about this idea of investing in nature and conservation for the purposes of supplying water? Well, because we have a very famous and very at-scale example. This is sort of a world where we actually shouldn't be talking about pilots at all, in a sense, because we have a city of 12 million people that depends on that very idea. And it's somewhat disheartening to me that, in fact, I still live in a world of pilots. This is New York City. I lived there until last week, in fact. You can see Manhattan at the very bottom there. Many of you probably know this story. New York City gets its water from protected catchments in upstate New York, particularly the Catskills reservoirs at the very, very top there. If I had more time, I would tell you the details of this story, which are not quite as nice as make them sound. This wasn't a pristine natural environment that got protected. This was was an operation where New York City grabbed a lot of land in the early 20s at the time of a fellow called Robert Moses, which some of you might have heard about. But what's interesting is that the fact that New York City gets its water from upstream protected catchments has changed the economics of the utility of New York City. The operating costs of the DEP, which is the utility, are significantly lower than you'd otherwise expect. The primary operating cost is actually labor, not energy, not chemicals and others. And that's in part because they can rely on relatively clean water that comes down gravity-fed into their into their system. So I think it's a legitimate question to ask whether this is a model that's applicable to other parts in the world. And there was a famous, oh, by the way, it's also pretty, right? So if you go up in the Catskills, that's what you get. And I say that only half in jest because the fact that it's pretty is actually the reason it exists, not the business case that I'm about to show you. At the time, it was argued on the back of recreational value, not economic value. But the point is, if you protect the Catskills and you supply this kind of place, turns out you can save a lot of money. A new water treatment plant for the city of New York would cost you capital costs in the area of $10 billion. Watershed protection over 10 years, which is just about the horizon that you have if you have the cost of capital of DEP, would take it about $1.5 billion. This is a synthesis of a study that the National Academy of Sciences did about 15 years ago. So it seems like a good idea. And the question that we're trying to answer is, how would you get this to happen many, many, many times over around the world? As a conservationist, the result is you protect a lot of nature, and as a water person, you provide cheaper water to lots of people. Let me just frame this in the way I think about it, and I say this because it introduces some words that matter. We've talked about a lot of water security, and there's a tendency to talk about these types of solutions in terms of payments for ecosystem services. That's a subset of what I worry about. I worry about ecological integrity. Ecological integrity can deliver ecosystem services, but there are lots of common property goods that come out of ecological integrity that may not deliver ecosystem services, and that matters. Somebody yesterday asked me about kind of how do we manage what we don't know in the future. Well, protecting ecological integrity is one way of doing that. We actually don't know exactly what it gives us. So how do we protect ecological integrity and achieve water security? The innovation that the Nature Conservancy and some of its partners have introduced maybe 10 years ago now is this idea of a water fund, which is in some ways an inappropriate nomenclature because it is actually not a fund typically, but not a fund in a financial sense. But it is a structure, and it is an innovation in institutional architecture. And what it does is it tries to solve the following problem. The reason the model of New York doesn't typically happen is that the jurisdictional boundaries of the utilities typically don't encompass the watershed that they depend on, and those boundaries are hard to penetrate. And so what we've done over the years is created an institution called the Water Fund, which aggregates a number of stakeholders in a formal set of agreements that connects the providers of water, so the people that live in the watershed and operate in the watershed, with the downstream users of water and beneficiaries of those services. Water utilities, but not limited to water utilities, generators, power generators, industry, and generally citizenship. Turns out this model, as simple as it seems, is complicated to set up, but we've now gained some experience in doing it. And so I'm happy to report that even though we might live in a world of pilots, we now have close to 60 of these pilots around the world in some form of development. So we're starting to get to some degree of scale, at least in replication. And the question is, well, what impact do these things have? And does it matter that we've done so many? Yeah. So I'll give you a couple of examples of these, and I apologize if I go a little quickly, but we have limited time. The first example I'll give you is an example from Sao Paulo, from that first picture. This is a picture of Sao Paulo on the left. On the right is the formerly forested watershed that supplies water into the Cantareira system. This is a picture from Extrema in Brazil. It turns out that this area has been deforested by about 70%. This is part of the Atlantic forest, which is 150 million hectares of land originally, much of which has now been lost to forestation, and that's kind of what it looks like. Well, it turns out the reason I bring this example up is because this is one of the places we've been working for longer, and we've come to the conclusion that not only reforesting this landscape actually does create water benefits, both in terms of quantity and quality, particularly sedimentation, but it's eminently it's eminently doable from an economic perspective and may even be financeable. And the distinction is important. I'll come to that. So these are some of the basic economics of it. It can be done. There's a bunch of costs that are associated with the amortized cost of reforestation, land rental operations. I won't sort of bore you with the details, but the point is you can account for most of the operating costs of doing this, and you can think of this as the exercise that you do in a utility. And then there are a number of sources of revenue that can pay for these costs. And these are not economic revenues, they're cash, right? So people willing to pay. Municipal revenue, we can actually build some of these costs into the ratepayers structure. And then there's a federal program, a watersheds committee, there's a water producers program that supplements that. And it is a form of subsidy, I grant you that, but it is a way of getting these systems to actually work. The question we're trying to answer here is, can this therefore be financed? Could you imagine setting up this vehicle where you actually do all of the work up front and then securitize essentially the revenues that are a promise from creditworthy counterparts to pay you into the future? And that's kind of the work that we're doing now. So even though it's a pilot, I think we're actually having the right conversation about the role of these types of things in a modern utility. The second example I wanted to give you is more germane to the conversations we're having here, and it's from Nairobi. This is the Tana watershed in Nairobi. Sorry for the number of maps here. The point I wanted just to show you, let's see if I can, the Tana watershed is a pretty important watershed in Kenya. Most of you will know more about it than I do, I'm sure. It's 90% of the water. There are 5 dams in the mid-stem that actually represent, I think, 70% or close to 70% of the power generating capacity of the country. And then, of course, Nairobi depends on it. So if you look at this kind of little area here, which is blown up here, there are a number of diversions that take water out from the river into the Nairobi water system. And one of the problems with this watershed is that the watershed is highly degraded, particularly because of land use along the sides of the watershed, in many cases associated with smallholder farmers and their activities. Also, there's tea, coffee, and there's a bunch of different activities here. The point is that the challenge is that Nairobi, because of that, because of the turbidity of the water, in part at least, faces a 30% supply deficit. It's not only because of the turbidity of water, but the waterworks in Nairobi are under-dimensioned compared to the need of the city. And one of the problems is they have shutdowns because of the sediment loading on the river. And the other problem is these dams down here lose about 4.5 million cubic meters of storage capacity every year, because the sedimentation rate is actually twice what they have been designed to receive, right? So here you have a big watershed that matters to the city, matters to the downstream users, where conservation activities, improving, ameliorating the degradation, might have a real impact on the outcomes. And in fact, it turns out, again, I don't have an enormous amount of time to go into the details, but we've done a fair amount of work looking at different conservation practices, riparian buffers, agroforestation interventions, and so forth and so on. Essentially, they boil down to managing working landscapes along the sides of the river. And we've done a fair amount of work to think about how would you spend something like $10 million to be very, very targeted in improving the conditions of the watershed and achieve something that matters, right? And so we've applied a number of tools in collaboration with the Natural Capital Project of Stanford University. You can see some of the maps that result of that. These are the places where we would apply some of these measures. And the good news is that there's actually quite a lot of return implied by this work. I'll give you some figures here that I had to write down to remember, but you'd expect, for example, with those target interventions to get a 50% reduction in sediment concentration, particularly at points of high flow. You'd expect, for example, the Mazinga Reservoir to have an 18% reduction in sediment loading. That's the reservoir that's downstream of the dams I talked about. You'd expect about a $3 million per year increase in yield from a number of the farmers there, and you'd expect something along the lines of $250,000 of avoided filtration costs for the Nairobi City Water and Sewerage Company, which is one of the members of this thing. So I guess it's work in progress. The Water Fund was formally set up last year. We've already touched about 4,000 farmers in the watershed working with partners. As you might imagine, a lot of the challenge have to do with delivery, right? Delivery at scale, this kind of work. But it's quite promising. Last thing I wanted to tell you is that it's quite promising, and it can happen in many, many different places. We spent some time last year doing some work that actually a graduate of this very program led, called Daniel Shemi, and he and colleagues took about 500 cities across the world and asked the question, where do conservation activities have conceivably a positive financial return and a positive conservation return? Where could you do this in a way that makes economic and conservation sense, right? And so they evaluated all the dots on this map and essentially had to find out where the water was being sourced from, had to calculate what the land use patterns were. It's a fair amount of work, and let me sort of not spend too much time. A lot of the work was microeconomic, figuring out how much it would cost you to do this stuff. As you can imagine, there was a lot of layering of data. Again, if anybody's interested, I'm happy to talk to you, but let me go to the punchline, which is we looked at 5 conservation practices. You can see what they are there: forest protection, reforestation, agricultural best management practices, which are a whole bunch of activities. And the punchline is this, which is that we calculated that about 700 million people could benefit from these conservation solutions. Now, I should caveat this. This is not the same benefit that you get by providing directly a pump to somebody, right? But in the spirit of the SDGs of providing sustainable water resource management to all, water management to all, 700 million people would benefit from that. We're talking about some 6.4 million hectares of targeted land. That's a lot of land. Ethiopia is about 100 million hectares, so that gives you a sense of scale. But the interesting thing is that for 1 in 4 of those cities, according to our calculation, for 1 in 4 cities of those 500, 1 in 4 cities, the sheer savings from avoided operating costs, like Nairobi, where you save money because you're having to treat less turbid water or less nutrient-loaded water, those savings are enough to pay for the conservation. Okay? So I'll leave you with that. If you're interested in finding out more, you can find the report at this address, and thank you for your attention.